next group has been working with C40 Cities Finance Facility, or CFF. Jake Sanum will be presenting, and their faculty advisor is Susanne DesRoches.
If anyone does care, I also put in my best pair of earrings today. They are snakes. They might be a bit harder to see. I support the decision to wear cool earrings. All right, so let's get started. Our project is measuring multi-sectoral resilience benefits for climate adaptation infrastructure. Susanne, our advisor, thank you for your support. As well as our team, thank you to everyone on our team. Great work this semester. Special shout out to our managers. All right, so first and foremost, we want to talk about why climate adaptation is so important. Roughly 50 to 60% of the global population is living in cities, and climate change risks are only going to become more and more extreme in our built environment. Climate adaptation is going to be important because there's a certain amount of climate change that is now irreversible. So we have to be able to design systems that are going to be able to anticipate these changes in the next 5, 10, 15, 50 years. Climate adaptation takes both the natural environment as well as the built environment and can combine it into one solution. Some examples might be green infrastructure such as urban parks, nature-based solutions like mangroves, which we just learned a lot about, and then any types of blue infrastructure to help address water systems. Some of the current challenges with climate adaptation projects currently is that a lot of the overall international climate finance is being geared towards mitigation projects. Part of the reason for that is climate adaptation projects have a difficulty quantifying the overall project impacts and benefits, whereas mitigation projects are able to utilize more commonplace metrics such as GHG emission reductions. With that in mind, though, there are a lot of challenges that adaptation projects do face, and adaptation projects, though, are proven to have a much higher cost-benefit ratio than mitigation projects when actualized, and this can range anywhere from a ratio of 1 to 2 to 1 to 10, depending on the adaptation project in place. As mentioned, our client is the C40 Cities Finance Facility. They are a partnering organization of the C40 Cities Climate Leadership Group, which is a global network of 100 different city mayors working to address climate change in the built environment. Our specific client, the CFF, they are working directly with these mayors across the board to help build out adaptation projects, prepare a project for financing, and help gain access into different financial opportunities. I had earlier mentioned how it is challenging to quantify the overall impacts of an adaptation project. Our client in particular is using one metric to be able to look at the overall impact or assess the overall impact of a project, and that is through the total number of people that are going to be impacted by a project. With that in mind, our goal is to be able to help them derive that calculation. In doing so, we had to create a methodology for quantifying the impacts of the adaptation projects they are currently developing. We were able to do that through a baseline assessment, as well as identifying what types of climate risk indicators these projects are going to be looking at. In the example of an urban park, we're going to be addressing the area before the project was implemented, understanding what types of factors go into the area around it, and then what kind of climate risk is this urban park going to solve for? Is it going to look at flooding, heat reduction? There's a lot of different factors that go into it. Then the next part is being able to calculate the total number of people benefiting. Currently, our client does know how many people are roughly going to be benefiting from a project. What they don't know is how that correlates or how that's actually derived. Our team worked to create a very robust Excel tool that is able to correlate different types of climate risks and their indicators to totalize or to figure out how many people are going to benefit from an adaptation project. Speaking of the projects that we worked on, we had 3 different projects that we looked at. The first was a landslide prevention and water retention project in Salvador, Brazil. The second was a riverine management project in Cape Town, South Africa. And the third was an urban park and river revitalization project in Medellin, Colombia. For this presentation, we are going to walk you through our calculations for Medellin, show you how we derived our total number of people, and then show you a summary table at the end of all of our different projects in review. A bit more specifically, this urban park project in Medellin is located in the northern district alongside the Medellin River. It is located in a relatively poor district of Medellin that currently doesn't have access to a lot of green space. You can see by the renderings on the left that this is a portion of what the park is going to look like, as well as you can see that it is going to serve the population that right now doesn't have a nice park to go visit. While it is granting residents new access to this park, it's also going to be solving for different climate risks that Medellin is facing on a day-to-day basis. Those are risks due to urban flooding, challenges in urban heat, as well as addressing concerns to health and safety. Our first calculation that we did was understanding the overall benefit that this project is going to have on flood mitigation. The total area of the park is represented in the light green shaded region on the map to the right. And then we created 3 different impact zones. The first one here is our high impact zone. These are the people that are going to be experiencing the most direct benefits from this urban park project. This was based off of historical flood map patterns, as well as soil consumption characteristics, or soil absorption characteristics. And then we multiplied that by our overall population density in the area to arrive at the total number of people that are going to benefit in the high impact zone. Our medium impact zone is going to include a population that is going to be able to experience any direct as well as any co-benefits from this adaptation project. And then the total impact zone are people that are going to experience any sort of ancillary benefit or any sort of overall impact from this park in a positive way. The next calculation that we looked at was reductions in heat island and urban heat. Again, you can see the park area shaded in green, and the blue shaded region is what we're calling our park cooling area, or park cooling distance. That is from a pre-existing equation, which was based off of a statistical regression model that compared park size to overall park cooling area. We then took that equation as a percentage of the overall borough surface area to understand how exactly or where the cooling extent is going to extend to the overall population, multiplying that by the density of borough population to arrive at our total number of people. Health and safety. We looked at this through the lens of understanding how many people are going to avoid a waterborne illness as a result of this flood adaptation project. At any given moment in time, there are a baseline number of people in Medellin around our project that are currently experiencing waterborne related illnesses, whether that be something similar to a skin irritation, to a thing like pink eye, or to something more serious in the GI tract. Statistically, we can predict how many people are going to experience a waterborne illness after a flood based on different types of research that we conducted or analyzed. And then, assuming that this urban park project is going to greatly reduce or eliminate flooding within this area, we can take the delta between both populations to show that there is going to be a set number of people that could be avoiding waterborne illness as this park is in place. If you look at the prescription pad to the right, you can see that roughly our team assessed that would be around 28,000 people that would be avoiding a waterborne illness as a result of this project. These are our 3 projects that we looked at in review. The metrics that we looked at across all 3 projects are pretty similar. That's flood mitigation, changes in heat, and health and safety. This is not to say that every single climate adaptation project is going to be looking at these 3 indicators. There are a ton of different climate risks and indicators that our team was able to identify and that we could have looked at. But this was at the direction of our client because these projects are very focused around water systems and water flood mitigation. But this is a great way for our client to be able to make differences between different types of projects, their overall scope, and understand exactly how different projects might be able to benefit a different population across different risk indicators. Again, the highest impact is coming from flood mitigation, as a lot of these projects were addressing flooding as the main source of climate risk in the area, but it's a great way for them to make differences between them. Finally, we had talked about this robust Excel tool. This tool is meant to be used across both the CFF, our client, as well as any government officials that might be utilizing this tool. Not going to walk you through all the calculations here, but at its core, in the first column, you have what the calculations actually are, and then in the second column are the pre-existing equations, and you input localized data, and then any helpful notes that are needed for each of the steps, and then in green, it shows you your total number of people benefiting. Looking into the future of how we want to really increase the validity of the assessment that we did and continue the work that we've done, I think a common theme here has been that a lot of projects data can be very biased. So being able to gain more access into data streams and data types where we can replace proxy data with localized data, and then our project scopes of work for these adaptation projects, these are still under development. So we had to make some general assessments or assumptions based on the existing conditions that we were outlined with. And then one of the key things that we have talked about as a group is the idea, or the issue rather, of housing displacement that's associated with these adaptation projects. You might have noticed in the graphic that we displayed for the urban park, there might be some people that are going to be displaced. And when we came up with our renderings, these were just general rough assessments. The project is still under development, so our client doesn't know exactly what it's going to look like, so we had to make some assessments, and they do have a team that is specifically addressing that issue of housing displacement, and they have a system in place to address that. And that is it. Happy to take any questions.
Thank you, that was really good. You talked about how climate mitigation projects get more attention than climate adaptation projects, but then that there's more success in the impacts of climate adaptation projects. I would love to understand more why that's the case. You know, you went over this example, it was really interesting to see. I would like to, what are the main learnings for you in order to recommend more investment on climate adaptation projects versus mitigation, or just on top of that, in addition to that?
Yeah, that's a great question, and that's something that our team discussed a lot about. Currently, climate mitigation projects are utilizing a lot of different techniques that are very numbers oriented. So they can, a project may be able to predict how many GHG emission reductions are going to be reduced each year. Climate adaptation projects are looking more at people-centric values. So the use case there is being able to understand how many people are going to benefit from this project, how many people are going to be in this benefiting population after a project is completed. And the challenging part about adaptation is that it's making assumptions about what the built environment might look like in the future. They're building systems that are going to try to adapt to changing climates, whether it's rising sea levels or changes in heat intensity. So these projects are to be able to generally make a rough assessment at how many people are going to be impacted. And because they can change over time, that's where the value comes, is that they're able to really provide a continuing support system as this project has gone under development. So it's going to continue to only increase in use as it progresses throughout time.
Great presentation. The thing that really catches my attention is the proxy data versus the localized data. And I'm wondering if you have a recommendation of next step to try to get closer to the real data.
Yeah. So as I mentioned, the C40 Cities team, they have like on-the-ground teams that are currently building out the scope of work for the projects, these different types of parks. And because they are very local to a very specific population, we were just using general public data sets. But when they start to go modifying the scope of the project as they start to build it out, that's when they can start collecting very specific population density data. That's when they can start collecting very specific hospital data to look at different overall illnesses that might be benefiting or changing based off that. So once they start on the ground with understanding the overall project scope, then they can begin to replace that proxy data with localized data and use that in the measurement and verification phase.
Thank you. I really enjoyed the presentation. Thank you so much. Really quick question. On the end, you mentioned that displacement was built into the project, and I was curious about, did you face, or the project faced any resilience from the inhabitants, or if not, was that then level, like sold on a city level? I think in the future, especially climate adaptation projects are more and more important, like as you said, and it's important to get the buy-in from local people, so there's no resistance.
Yeah, exactly. So I think, like you said, it's a very challenging topic, and we did face a lot of issues with it. With discussions with our client, the general consensus was that we were going to omit the overall housing displacement as part of the calculations that we were going to do. They have a very specific team that is working on understanding the overall housing displacement, and their goal is to make sure that these adaptation projects are going to benefit everyone. So if people do have to be displaced, then they are going to be relocated to a place that is going to improve their quality of life too. So I think their mission is very sound, but I think in terms of actually building that out, they're probably going to face some challenges. That's an issue that our team was not discussing because that's out of our work, but a very important topic to address.
Thank you.